All right, here's chapter 10, section 2. Here's an example problem. This is number 11 from the homework. So in a survey of 34% of the respondents stated that they talked to their pets on the answering machine or telephone. So this is what's known, 34%. A veterinarian believed that this result is too high, so he randomly selected 250 pet owners and discovered that 70 of them spoke to their pet on the answering machine or telephone. So he collected a sample and is going to check his data against this known proportion of 34%. So does a veterinarian have a right to be skeptical? Use the significance level of an alpha being 0.1. So in this section, we're going to have to look at this. With the proportions, with the null hypothesis, we're always going to put equal to for what we're doing, and 34%. My alternative, that's what we have to decide based off of the context. It says a veterinarian believed that this result is too high. So that means he thinks it's less than 0.34. That would be our alternative hypothesis. So now we have to find a p-value using a technology. This is the method that I prefer. There's a p-value approach and then a classical approach, and we'll look at a classical approach too. So if I go to StatCrunch, it's going to find a p-value for me really quick. So we had the believed was 34%. It was 70 out of the 250. So if I go to Stat and I do proportion statistics, and I have one sample, and I have a summary of the sample, this is the exact same place we were when we were doing confidence intervals. But now we're just going to do a hypothesis test. So my successes were 70 out of the 240, and then my believed proportion was 34%, and we thought it would be less than because we thought that was too high. Once you punch in all your numbers, hit compute, and out we get this p-value. So this p-value tells me there's like a roughly 5.7% chance of me collecting data like this if it really is a 34% chance. We actually got 29%. It was a lot lower than 34%. And again, about 5 to 6% of the time, because of the p-value, it's only going to happen 5 to 7% of the time that I get a sample of 240 people, and only 70 of them state whatever they stated. So I'm going to type in my p-value over here of 0.057. 0.057. Oh. Did I do something wrong? Less than 34%. The p-value is totally 0.057. Let's see if I typed in a wrong number. 70 out of 250. There we go. And I will be the first to say that I make mistakes. I read the number wrong. Let's compute that again. And when I compute it, I get 0.023. So even a smaller percent chance of happening. So 0.023. There we go. So you got to put in the right numbers if you want to get the right p-values. And so now I have to determine, do I want to reject or fail to reject? Since I only had 0.023, it's a small percent chance that I were going to get a sample like this if the real population was 34%, said they talked to their pets. I'm just comparing it to alpha. If my p-value is less than alpha, I would reject the null hypothesis, saying that I don't believe that the real proportion is 34%. I think it's less than 34%. There's a saying, if the p is low, the null gotta go, or the HO, I like to say, if the p is low, the ho gotta go. So since my p-value is less than my alpha, which is 0.10, so 0.023 is less than 0.10, there is sufficient evidence to conclude that a true portion of pet owners who talk to their pets on the answer machine or telephone is 34%. That's not correct. There is not sufficient evidence to conclude that the true portion of pet owners who talk to their pets on the answer machine is less, so that's not correct. There is not sufficient evidence to conclude that the true portion of pet owners who talk to their pets on the answer machine or is, so I don't believe there's enough evidence to say that it is 34%. Or the last one, there is sufficient evidence to conclude that the true portion of pet owners who talk to their pet is less than 34%. So if I'm rejecting the null hypothesis, that means I don't believe it's this, which is kind of saying that that part gets a little confusing. And apparently, that's what I need to put. So there is sufficient evidence. So let's put that there is sufficient evidence that the true proportion of pet owners who talk to their pets on the answer machine is less than 34%. Since we rejected the null, we have sufficient evidence to say that it is 34% or is less than 34%.